Welcome, everybody, to this session of the Technical Steering Committee for the live control plane migration topic. Ashish and colleagues will present. We have prolonged the session by half an hour today and kept the agenda or changed the agenda slightly so that we only do at most 5 minutes for the recap part, because everybody has already read the proposals. And then spend the majority of the time with discussion and feedback and questions and everything, and the last 10 to 15 minutes ideally for the decision part. All right, then please get started with a short recap.
Is my screen visible?
Yeah.
So,
yeah, but I think it might be the wrong screen, because we just see the
wallpaper. Is it like visible now?
Yeah. Slides.
Okay, so hello everyone. So in this TAC meeting, we'll be presenting live control migration along with Sonu, Shafiq, Shisha, and me. So what is the motivation behind this? The existing CPM. 1 second. Sorry, I think I shared the wrong. Sorry, but. Okay, so what is the motivation behind it? The existing control plane migration flow is mature, but it still causes 10 to 20 minutes of downtime for shoot clusters. For mission critical workload, this downtime may not be acceptable and can block some important use cases. That's why there is a need for migrating the control plane without API downtime. So what is live CPM? Live CPM is a new migration mode that allows us to move a shoots control plane between the seed without any API server downtime. And it does this by bringing up the destination control plane in phases while the source control plane stays active, and by carefully synchronizing state and connectivity between both the sites. So what are the goals? The primary goal is to keep the shoots queue API server available end-to-end during the entire migration process. In parallel, we will keep the HCD data strictly consistent between the source and the destination, and keep the VPN tunnel functional, so log, exec, and webhook keep working. As a part non-goal, live CPM will only be supported for HA suits. We are not planning for non-HA for now. Non-HA clusters will stay like only support the classic CPM. And we are not allowing suit spec changes during the migration. And for now, live CPM will only be allowed for close distant region, and it will not be supported for high latency distant regions. And this is not the replacement for current CPM. And we are also not preserving the historical logs and metrics on the old seeds. So what are the prerequisites? So for CPM, live CPM assumes that both the seeds are in non-distant regions, which can be validated via the scheduler config map with the latency information. Both seeds must be healthy, and it will run the same gardenlet version. As a high-level approach, the migration is orchestrated by the gardenlets in both the seeds using a step-based protocol whose progress will be recorded in the shoot status. We'll bring up the core components first, like API server and HCD on the destination, while the source will stay while the source stays active, backed by a temporary 6-member HCD cluster and a temporary VPN solution, like VPN path from the destination to the source, from the destination seed to the shoot. So as a changes in a Gardener API, the major change is a new status field on the shoot that tracks the migration as a step-based process for both the seeds, which will record step name, status, message, and completion time for both source and destination seeds. So this status will ensure synchronization between both the gardenlets, like source and destination gardenlets. So like both the gardenlets will wait for a particular step to finish, then only it will perform the next phase or the next step. And we'll also be introducing some annotations. So normally changing the seed spec seed name to a different seed triggers the standard control plane migration. But to opt for the CPM, user will have to add a live migrate operation annotation. And if that is present at the trigger time, we will execute the live flow instead of the classical CPM. This annotation will be forbidden for hibernated shoots because that brings no benefit in that case. Next is the allow distant region. So by default, we don't allow CPM for distant regions. So, but still, if user wants to proceed with the risk, they can just annotate with this annotation and proceed with the CPM with the known risk associated with it. The next one will be about live migration. So if the destination member cannot join and the 6-member cluster fails, like cluster never becomes healthy, that usually may indicate latency issues or like often because migration was forced across the distant region. In that case, we will allow operator to annotate the shoot to abort the live migration and switch the seed name back to the source and let the gardenlet revert to the standard CPM while cleaning up the extra HCD members. And the last one will be force shrink HCD. So if the HCD is healthy, but the destination API server is not able to come up, this might also be the reason because of like latency between the two regions. In that case, operator can use this annotation to force like early shrinking of HCD to 3 members in the destination and accepting a brief downtime to restore a healthy API. 6-member HCD. So code trick for data consistency is temporarily expanding the HCD cluster from 3 to 6-member with 3 members in the source HCD and then 3 members in the destination, and then shrinking back to the 3 by removing the source member after the migration process is complete. To support this, HCD Druid will add support for multiple peer address via load balancers and a bootstrap existing cluster mode and the use of skip SEM verification flag for peer certificate while still keeping the TLS encryption during the like whole phase, whole process. VPN strategy. So VPN connectivity is required for several user visible features. So during migration, we bring up a temporary VPN from the destination seed to the source to the shoot. And once the like destination VPN is stable and the source is torn down, we will remove the temporary connection. So I think that is basically it from our side. So we'll just open for questions.
Okay, cool. Thanks for the short refresher. Then we can directly jump to the questions feedback part. Does anybody want to start? Just go ahead.
Okay. So you mentioned briefly about certain error scenarios when the etcd is scaled up to 6 replicas. In general, do you see just those two options? So basically that the scale up fails from seed 3 to 6 instances, and then we kind of abort and fall back to ordinary control plane migration, or that we kind of force to the target seed, force etcd to the target seed and kind of again do something similar, or yeah, incur some downtime and accept that it will be down for a short period of time and then basically do the same thing? Are there other error scenarios that you can envision, or is it basically always an option if something fails to go back to usual control plane migration? Because the process seems very involved. There are a lot of steps. I assume most, if not all of them, can end in some failure state. Do we want to automate all of that, or do we think we can automate all of that, or is it something we do a best effort and then operators need somehow to handhold the thing nevertheless? I was wondering, as you just picked basically two explicitly mentioned failure strategies, but not so many apart from that.
Yeah, so the first about live migration, it's only if the 4th member itself is not able to join. So at that time, we don't have because we would not have created any other resource except for the load balancers. So that's when we were thinking we will allow an abort option. But after that, if the 6-member has cluster and we have deployed stuff in the destination, then maybe it's not a good idea to automate. It need too much effort. So that's when we will just try to restore the HCD, because if the four members have joined and like they formed 6-member once, they should be able to do it again. So in that case, we will still have to fix the quorum loss and everything manually, and then proceed with the migration. But the about part is only if the 4th member itself is not able to join and we have not created anything in the destination, so that we can automate. And the force string HCD is also a case where the QBP server is not able to come up because for linearized reads, they need quorum. And because of the latency, the initial cache is never able to get populated. So in that case, the solution is that if all the members are there in a single cluster, if quorum is already there in the single cluster, then QBP server will be able to come up. So if they are failing, so we should accept small downtime, and then there is no point in recovering because QBSA will never be able to come up even if we form the 6-member cluster again. So we shrink the HCD a little bit early so that all the members are already running on destination. Then yeah, KAPA should be able to start and we should be able to proceed with the rest of the stuff. So, the idea was to automate most of the things, but yes, some manual, I think, intervention will still be required. Apart from these failures, all other failures should be retriable and yeah, solvable. That's what our idea was saying.
Maybe just a question on my side again in this direction. You said that all failures should be retriable. So this would then mean that, let's say, one of the gardenets restarts, or maybe both gardenets restarts at random times during the process, or there is any other error. Would they have to sync up again on a step-by-step basis, or would they just have to get to the current step that they had reached before running into this error?
It should be the second. Yeah. The flow should be idiomatic too.
All right.
This is not what we currently do, right? If Gardenlet restarts, we always start from the beginning, which also means if we update Gardenlet while a shoot operation is in progress, we start from the beginning because it might be a different flow and we don't just start by continuing the step that we previously tried. Do you see any conflicts with that? Could lead to some irrecoverable states? Maybe we don't have to answer it now, but we should give it another thought, I guess.
Yeah. Yeah.
You mentioned that the gardenlet in both the seeds should be of the same version. And how do you enforce that it after you started it doesn't change? So if someone upgrades the landscape and there are pending control plane migrations which were started before the upgrade was initiated, how will that work?
Hmm?
We have not as of now decided that part.
Yeah. Maybe it can wait till the other party is also updated. Because I think at least a gardener don't support like all the gardeners are anyway updated together as of today. So eventually they should be on the same version. So maybe we can wait on till that.
Okay.
And I mean,
So it'll
yeah,
be inconsistent. It'll stop because it finds that this is happening and hence restarts after both the seats are on the same version.
mhm. Yeah, we'll have
Okay.
to work on that. Yeah.
I was just thinking because of what we are
Mhm.
discussing.
I would like to dig a bit deeper into the concrete exposure of the etcd members. For one, there was some slightly misleading sentences in the proposal, which talked about Istio gateway objects and virtual services. And there was another picture showing that there were individual load balancers created for the members. Can you go briefly into how we will expose the individual etcd members?
Okay, so when we did the very first testing, we did with the load balancer, exposing each and every member with the load balancers, and then we later tried with the Istio setup also, and Istio setup works. So in the future, this diagram will change, and we will go with the Istio settings instead of creating load balancer for each and every pods.
When you say in the future, do you mean like after the
When this
session
will
you
be
will
implemented.
update the proposal, or
Yeah.
is that like a second phase in implementation?
We'll update the proposal itself.
Okay,
We have
so
already tried.
Mhm. So meaning each etcd member will get a virtual service probably and a dedicated DNS name that is exposed via the default Istio ingress gateway. Is that correct?
Yeah.
Yeah.
Okay. How are the DNS records constructed in that case? Is it like similar to the ingress DNS names?
For the testing, we were doing something like some etcd something, and initially we were adding the temp etcd something like that, and member names. So more or less, we'll go with that idea to have just temporary names, and once the migration is there, things will go. So the names, I don't think it's much of a concern. What we are naming the DNS records.
Will the DNS names be included in the peer certificates? Because one bigger concern of the proposal is skipping the client, the peer certificate verification. I imagine that will get easier if you have like deterministic DNS records for the individual members.
No, that will not.
Yeah.
So I think that the problem here is that each etcd will check whether the certificate it gets from a peer matches the IP address the peer connects from. And basically the DNS name maps to the Istio load balancer, and the connection where the IP comes from might be the NAT gateway, or it might even be, if it comes through an Istio gateway, again, some internal address. So that doesn't really match up.
Right, so it wasn't about validating the server certificate, but rather the other way around.
Yeah.
Oh, okay. Sorry for that. Mhm.
No problem. That's a really fun topic with etcd. But on the positive side, I found out that the peer skip sun client sun verification is no longer, or seems to be no longer experimental with etcd 3.7.
3.6, I guess.
3.6.
Okay, I found it at 3.6 still was experimental, but at least at some
Okay.
point in time it will no longer be experimental.
Yeah.
And then another unrelated question was about the leases. So one section described that the components acting in the shoot should also perform leader election in the shoot. I was wondering if or which components are still performing leader election on a lease in the seed.
For now, I think only MCM.
Okay.
Yeah,
And we don't have
but
issue.
we don't have an issue because we don't allow changing the shoot spec during the migration. So yeah, MCM mostly, we'll scale down. So the machine should not change.
There might still be some. So we haven't had issues with, well, not issues, but yeah, cluster autoscaler still works. And if you do, so yeah, because this is live control plane migration, I guess users might still create workload or workload might get descheduled. So some nodes might get underutilized. This would probably be detected by cluster autoscaler, and it might try to change the number of machines or change the replica on machine deployments. This is also something that I meant to ask. So in this line, if you've thought about it or how you could handle it in this case, whether it's at all a problem, because I know that some people might actually expect scaling to occur at all times.
I was also a bit confused about this whole controller section with release management, because I thought controllers we will not run them in parallel in both the old and the new seed. I thought we will just keep them running in the old, then move over the critical components like etcd, Kube API, and VPN. And then we could directly move over the controllers, right? Without making them HA, so to say. So there would not be any lease sim conflict if we do it that way. We can just shut them off or shut them down in the old seed and then redeploy them in the new seed. That's it.
The issue with that is, so we move the DNS record to the new seed only at the end of the process, but during that time, like during the
So the idea is that if we move the components one by one, like first scrape down from the source and then deploy in the destination, there will be downtime for those components.
like the
And
books.
like webhooks, for example, Lacom, where the server is running in the seed and webhooks are in shoot. So to prevent all those kind of scenarios, we want stuff to be running at both the places and all the time. So if the leases are in the shoot, if we deploy the all those workloads or all those control plane stuff at the both places, we'll have the advantage of like one will be taking over whatever is working, whether it's in the source or destination, something will be working at all the times. So that's why you want all the leases to be in the shoots. And as of now, what we checked, there was only MCM lease, which was there in the seed. And for MCM, what we had the plan was more or less like for a minute or 2 minutes of downtime for MCM should be fine for us. Because
till the time DNS is switched, all the webhook server requests will be going to the old Kube API server, and the server should be running there to serve those.
I understand the general statement with webhook servers. Of course, we want to have them up, but webhook servers typically don't use leases, right? So this is only about controllers. And MCM is a controller, so I didn't get what you just said in the last sentence with the
example, other controllers like AWS load balancer controllers, and there are other stuff which is the control plane and some CSI stuff and all. So
they are all deployed like by the single control plane extension.
Yeah.
So how differentiating it as control plane or webhook? Will that be that easy?
What I didn't get, maybe one step back, is if we have moved over the critical components like Kube API server and what I mentioned, why we can't just shut off the controllers and redeploy them immediately in the new seed. So of course this might be 10 seconds of more unavailability or whatever. I don't know, but slightly more. But it doesn't matter for controllers, right? They are not really that critical that they have to be up at all the times.
Yeah, but those can create downtime, and we did not want that. That's why we thought of doing it like this way, where we deploy the stuff in if
Like user deploys the service, and then if CCM is not running, and then I mean it will be a small time period, but still.
It will be some seconds, right? You shut them down in the old, you redeploy. And even if not, there will be some least transition if you have them in both. So there will be some seconds of unavailability.
Yeah,
I don't
seconds or
understand.
more. Somewhat maybe 30 seconds or minute if deployments are going getting removed from here and then getting deployed there. So somewhat a minute, and we did not want that. That's why we were thinking of doing it like this way. Because when we are saying 100% availability, it should be more or less for all the components, whatever is possible, instead of just saying for QFA server and KCM and other stuff. But that would be implementing, that would be easier for us, and it will be less hassle, where we just scrape all the stuff from the source and then deploy in the destination. It will be much easier to implement. Yeah, that's true.
That's for sure. Yeah.
Yes. I mean, even today, controllers are not available 100%, right? They don't get requests, so it's not really visible for the people. And if one of the controllers goes down, it takes some time until the other one takes over the lease. And redeploying them is not too much different compared to this process. So if this makes the whole thing simpler, I would definitely go for that. So for the controllers, I would not be not try to be so perfect or whatever.
Yeah.
If
Sure.
it doesn't make a big difference implementation wise, fair enough. Then you can deploy them in both. But I think it's more complicated.
Yeah.
It will make our life much easier, because for extension we need to deal it in a much better way, where when we deploy the extension, we need to deploy the extension in source and destination, that all the components need to come in the destination. We need to like how GardenLet is managing, two GardenLets is being managed, they're communicating between each other. Same way we have to decide through the extension resource, there should be some status which should figure out, okay, now the destination can take over or not. So those kind of thing we need to implement if you want 100% availability for extension. The components which is deployed through the extension like CCM and all. But if we agree on this plan where we are fine with some downtime, then it will be
downtime. Yeah, when the control comes up, it's downtime. We'll still pick it up.
Maybe just one thing. Or if we directly first remove the controllers from the source and then bring them up only after that on the destination seed, I guess the only possible problem, which should be very rare, is if we for some reason use bin packing and all the nodes are full, so we have to wait for a new node to get up and running on which to be able to schedule the new controllers. But yeah, as I said, we usually expect controllers to not have too much resource requests, so it's probably not much of a problem.
Yeah,
Something to consider.
That's an interesting point. So did you consider this scaling, how is it called, VPA status checkpoints, or these resources that VPA has written in the old seed? Because if you just deploy the new pods in the new seed, this information will be gone, right? And then it might take some time until scale up is happening again. Did you consider this?
We have not considered the VPA thing, but yeah, that's a good idea to also transfer the VPA checkpoints to destination before moving the controllers. But
the status, I don't think it could. Can we?
I guess so.
No.
But yeah, we have to look into that.
I think we brainstormed like maybe last year or a bit before that a little bit on this topic, so I could also try to find some.
Okay.
I would like to understand the VPN a bit better. You mentioned that there will be a temporary VPN. What exactly is that, and how is it different from the regular VPN?
Okay, so the idea is people, at least the users would be creating different stuff in the shoot during the time of migration, and we don't want those webhooks to fail. To prevent these, we are creating the temporary VPN. So once okay. So in the source, first of all, let's say the first picture where the connection is something like this, where VPN 10 is between source seed and the shoot cluster. And once the QAPI server is deployed into the destination, we'll deploy the temporary VPN also. This is needed so that during the migration, if you not do that, and if you simply scrape the VPN connection and then deploy in the destination during that period of time, again, it can be another, I don't know, a minute or something, or 2 minutes, whatever. Number of amount of downtime of the VPN. During that time, all the webhook requests and from the user will fail. So if it would have been only the Gardener webhook, maybe we could have managed. But since the user webhook request also supposed to go through this, and we don't want to we don't want those requests to fail. So for that, a temporary VPN solution will be set. Configured, which is more or less same as how the current VPN works, except it's like another set of pods. So during that time, the destination control plane can talk to the shoot, and the request can pass through that. And once we have said both the connection is there, and the source cluster, the VPN, the QAPI server has been removed from the source cluster. At that time, we deploy the VPN again to the original VPN setup with the destination seed cluster. And after that, once the original VPN connection is established with the destination seed cluster, we just scrape down the temporary VPN. So this is just to have the VPN the webhook connectivity throughout the process.
And how do you selectively connect to either control plane, the old or the new? If I remember correctly, the VPN uses the Kube API server's DNS name also. Yeah, if we somewhen switch that, how do we connect to the old or the new control plane?
Can you ask that question again?
So
I
if I
think,
remember
so
correctly,
I can probably explain that. I think for the existing ordinary source seed cluster, we use the API server name to connect basically to the seed cluster's issue ingress gateway. And for the destination seed cluster, we need to have a separate temporary VPN name. So which would usually be the API server name, but now it can't be the API server name because it's we can't point to two different things at once, or we don't want to because then we have random selection. So the temporary VPN would use a different name, a different DNS name, which would point to the Istio gateway of the destination seed cluster. And then if you look at the right bottom, then when basically both are deployed, then when the API server switches over, then it also eventually points to the destination seed cluster. So you need, long story short, you need a second DNS name for that.
Yeah, which we are using. Yes. Thanks for that.
Okay.
Do you plan to reuse the DNS record resource to deploy this temporary domain name, or?
Yeah, we're using DNS record.
Yeah.
In this transient state, there are 2 VPN seed servers and 2 VPN shoot clients. How is the API server choosing which way to go to reach the shoot worker nodes or webhooks?
Typically, it will be destination will be configured with only temporary.
Yeah. So during the when we are setting the temporary VPN in the destination, so QAPI server is configured to use the temporary VPN, and once we this another VPN original VPN solution is deployed, then we roll the QAPI server again to use this original VPN connection, and then we scrape the this temporary VPN. So QAPI server where we pass like what exactly to use for the VPN connection, we will first you'll be using the temporary one, and then later we using the ones the original one once the original is moved to the destination.
Why don't we deploy the target picture on the destination seed right from the start? So why do we need to deploy another configuration for the VPN seed server? So what I already understood is that we have another DNS name for exposing the destination VPN seed server. Fine, I get that. And that's why we need another set of VPN shoot clients to connect to this in parallel to the old one.
Yeah.
But why does the VPN seed server need to have a different configuration? Why does it have to be temporary? And why will there be 2 VPN seed servers in the destination seed cluster in parallel?
Yeah. So for the second question, it will be like since the QFS, since the original VPN connection is already there with the source, and the at one point of time, both QFS will be running and are supposed to response. So when we deploy the QFS server first in the destination, and during that time the source QFS server is already there and it's functional. At that time, how the request should be reaching to a destination QFS server that can be set up through only this temporary VPN. So the seed server, the temporary VPN seed server is in the destination, and the original one in the source. So the thing is, both of them are present in the both of them are present at parallel time at different place. So that's why it's there. I'm confused. Can you ask the question?
Saying, so VPN seed is anyway in different clusters, right? So VPN shoot is same underlying, but seed is anyway in different clusters. So why do we need a temporary VPN seed server? Not the shoot. Shoot we need.
I think Tim is making a good point. I think with a in the shoot cluster, we need basically, because the pods are running in parallel, the old and the new one, we need some new namings, because otherwise, I mean, they clash. But for the seed server side, I think you can actually get around to not use different names, just use the same names, because anyway, you connect the API server to whatever seed server is running there, and that does not have to be also. I also don't see now a reason why there should be the need for a temporary VPN seed server, but we can test that or check that.
Makes sense. Yeah,
we can test that.
Okay, cool. Maybe we can also check if we can put the VPN clients into the same pod, so just doubling the number of containers. Would that be possible?
Wouldn't that be slightly difficult?
More complicated, or?
Yeah, it's a managed resource, right?
Yeah.
And then you have the managed resource that you originally have from the source seed, and then.
Yeah, probably it doesn't matter too much. Let's skip that question. Okay.
Okay, maybe something else then, or more to the VPN topic? Okay.
I'm good with the VPN now.
I was wondering about this operation annotation that you mentioned, there will be something called live migrate on the shoot to trigger this live migration. And I was wondering whether we cannot just detect this automatically, which kind of migration we want to perform. For example, for hibernated shoots, we would, of course, do the normal migration. And for maybe distant regions, we would probably also do it unless it's overwritten. And otherwise, we would by default do the live migration. So we can gate this via a feature gate in the beginning if you are unsure and so on. But why would, in the end, the user need to decide that explicitly?
Need to differentiate.
Yeah, we can think through that.
Yeah,
It can be done through the feature gate, and then automatically we decide which kind of migration.
yeah, if live migration is possible, then no user will say I want normal migration. So
By default, live migration.
when it's
I
possible.
think the general idea I find very appealing that we can, if we can decide automatically. What I don't really understand, that's basically a different angle. What is a distant pair of seeds and what not, and do we actually know that? If we know that, if we can identify that, then we can also automatically decide whether it's possible or not. If we don't really know that, if we can't really decide, then it's kind of difficult, because then you have kind of random
described in the
output
doc.
as 180 milliseconds, magic number. But
No, we have this Gardner scheduler config map, and as far as I understood, this is what is used or can be used to decide the distance, right? So
Yeah.
But I would also go Raphael's route, so using the live control plane migration by default, if the feature gate is enabled or whatever, if it's like a seed in the same region, for example. So if we know for sure that we can live migrate it, and optionally enabling the user via an annotation to choose live control plane migration if they know it's close by, whatever that means.
So just for forcing live migration, support the annotation. If there is no scheduler config map as such, so what if there is no config map, but they still want to,
Does that
There is no
exist by
config.
default, or is that something that operators need to set up explicitly?
Operators need to set up, but what if somebody, has a landscape without the config map? Then we anyway do a normal migration. That's what you're proposing.
Yes, unless the user overrides that, right? I mean, if there's no config map, you cannot decide it.
Migrating in the same region is anyways the main use case for this, correct? So it's about operators want to get rid of old seed clusters or anything. And they will probably shift the control planes to another seed cluster in the same region, right?
Yeah. But once we open the feature, we cannot stop people from using it for.
Not necessarily only about that, by the way, because sometimes there are no seats available in a particular region. So users might create routes where the control plane is hosted in another region with the hopes that someday we might create a seat closer to their shoot control planes.
Yeah, so I would say the default should be to have a control plane migration within the same bigger region or continent or something like that. It's not necessarily really a region in the hyperscaler sense, whatever that means. But
okay.
But maybe to these, since we already touched this, to this scheduler config map thing. So I think it's not really defined currently that the values in this config map are latencies, right? So this could be anything from Gardner point of view. Those are just weights or numbers or whatever. It could be latency, it could be kilometer, it could be anything. And if you want to use that for the 180 millisecond threshold, then we should define that, right? Otherwise, we might operate on the wrong data.
Yeah, we can just consider all the values and then work on the average and then maybe figure out some formula to do that. Yeah.
I mean, I had raised this in the internal review when I saw it the first time, but because this is brought up again, won't it make more sense to have this data fetch from public APIs between two regions? What is the latency? Because latency can change. And when you're triggering it, now you have a static config map, which was updated last year. And then who's updating it again? And then latency changes. And I mean, there's a dependency here. Maybe these regions have improved and we still don't consider them as good ones to go. And when I saw the first demo of the POC, we had those graphs from public APIs where we found out which regions had what millisecond. I mean, I'm just floating it here again, if that makes sense.
But it could also happen that the time that we fetch the value, it could be very low and then later it can go up or the other way around, right? So the real time
fetch the value when you
start
the migration. I tell whether this seed name change will fit into live migration. If it cannot fit into live migration, I just tell that go via regular route, because this data will change. So, and who will maintain this data?
That
I'm just curious.
But what if the value, real-time value, whatever you get is high and you say, okay, live migration is not possible and you start normal migration. But in reality, actually, it could have been possible. Maybe that one time that we fetch the value, maybe. So are you saying the public API is also always based on average? Then
I mean, we can check. We can have heuristics.
So our idea was if you are relying on this for scheduling, then that it should be somewhat good enough for this as well. That's what the idea was. But we can check this.
I mean, the scheduling is more to do with which is the closest seed. It's not which is the least latency seed, right? We just use it to figure out which is the closest neighbor we can put your control plane to for your infra region that you have chosen. But what we are doing here is...
I think it is latency based. So this is what where the numbers in the matrix are coming from. I think if I agree that with Shafiq, if we make a check before, then it is kind of random, and this means that it's unpredictable what will happen. I don't think you want in operations to have an operation which is unpredictable. And now it's not a live migration, even though you hope for a live migration. So I would rather have it predictable than have up-to-date numbers. If you want up-to-date numbers, then I think there is no other way but basically having agents in all of the seeds that are keeping track of the latencies to each other seed and then updating the table and have some time series data where you I don't know, look at these numbers over a period of a week or a month or something like this. But then it gets very complicated. So for now, I would also say it's okay to just go by this table because we have nothing else.
Sure.
I mean, if the operator anyways needs to configure or allow live migrations between different regions, we could also go for another table or metrics configuration, right?
Who is providing that? It's a lot of effort to provide that. And I also don't actually know whether it's a good idea that we have some Johannes said magic number. So it's not so magic in the sense that, I mean, these latencies between regions are published, but it's kind of a little bit magic in the sense of you want predictability also there. So if you don't look into the map and out of the sudden it's not a live migration and you have not notified a customer of a migration, the customer will notice. That's also not so good. So explicit is sometimes better than implicit, is I guess what I'm trying to say. So if you really think this is a hard problem with the latency, then I think it really makes sense to give that as an option to the operator. And then he knows, okay, I have to notify
because we know from the experiment anything beyond 200 fails.
Yes,
I mean,
yes,
anything less than 180 succeed eventually. It may take more time, but it'll succeed based on the size of the HCD. So for me, the config map is not really telling me this is less than 180. It is just saying it's close, but now we want this number because we have done enough tests. And maybe we have a feedback loop where we can figure out from existing migrations whether there are regions which are now even more than 200 is working, but for now it doesn't work. I mean, we are sure that it will not work for 250, right, Shesha?
Yes. As Ashwani mentioned, we did some feasibility testing, and we found that beyond 200 milliseconds, it didn't work. So that's why it's not a magic number. We did some tests and we found that 200 milliseconds. For safer side, we went for a 180 milliseconds. It hope it has answered.
And then going back to the algorithm that you proposed in the questions before, I would rather go for explicit then. But yeah, just that feeling.
Just to be clear,
I,
you mean
operator would want to know what I get in advance. Of course, if we say it's 180 and I can somewhere read it up, then I also know what I get, but it's a little bit indirect.
So our idea was just when they add the live migrate annotation itself, we can check the scheduler config map and validate it. So they'll not be allowed to add the annotation itself. That was the idea. So are we deciding
that you can do even when he's choosing the seed name, right?
No, but then it's like who will remove the annotation?
You will not put the annotation, right? You will just not let the migration to happen. That's what we are proposing, right? No annotation. Only annotation is for distant seeds if you want to force it.
Yeah, but then from Vedran's point, does it not make sense to have predictability? What if they were expecting it will live migrate and not expecting any downtime, and then we choose the whole migration? And
no, I was just talking about the check that you have clubbed to the annotation. I was thinking the check can be done also instead of annotation just on the seed name.
Annotation comes.
Yeah, but
okay.
That's basically not ensuring.
No. During annotation, there is no seed name. Only change in seed name you can compare the latency. Yeah. So
we need annotation in this case.
Okay. Fine. Yeah, I get your point. Actually, yeah, makes sense.
Maybe thinking one step further, so not only about latency, but do we have any guarantee that there is seed-to-seed connectivity at all between all seeds?
Just what I was about to ask, especially if you consider that we, for normal control plane migration, support cross-provider migrations right now. You could have a separate provider that's in a private network, so maybe, especially cross-provider, maybe we should include it in non-calls if that's the case.
Yeah.
And with this GEP also, we are not as such making the CPM as like automated. So it's an operator job to pick this next seed where the migration is supposed to happen. So these kind of sanity check we still expect from operator to have it.
Because currently also, I don't think everyone has the permission to update the binding resource, right? So only operators have it. So, I mean, but yeah, we can still allow cross providers, yes.
Okay, so for the annotation, we want to have it explicit because we don't want to surprise the user with our maybe automatic fallback to normal CPM if the region is too far away. And the user would otherwise assume there is no downtime. Okay, yeah.
When you say
Makes
user,
sense.
is it like the shoot owner or the operator? Because the operator is only allowed to trigger the migration.
Which is the user of this feature. Sorry.
Yeah, I just wanted to make sure.
Okay, yeah, fair enough. That's a good point. Then we keep it as proposed for now, and yeah. Okay. Your
Can
topic?
we move to another topic? Okay, I have a question about the member prefix names. I get that the etcd member names need to be unique even when spanning multiple seeds. So I was wondering whether this member prefix name field is eventually removed from the etcd cluster on the destination seed. Yeah, or if it stays forever.
I think the idea is to keep it always. So
and use seed name as the
so in future, once this member prefix is there, all the new etcd which is being created, be it any new shoot, it'll have the member prefix. Only the old shoots which is already have the etcd object, those etcd object will not have this member prefix. Everything new will have this member prefix.
And this member prefix will contain seed names and also
some random.
Yeah.
Okay, so I was wondering, because there's just the example with dest as the prefix, which would basically mean you would never be able to migrate it again. Okay, but we just always prefix the member names with the seed name. That's your plan, right?
Yeah, something like that.
Okay, that makes sense.
Small comment, because that reminded me a lot about self-hosted and the problems there with etcd, because there is also no stateful set. Would be good not to have a third way how to do it. There we also need identities. I don't actually know what we need.
For a self-hosted case, we have a separate API called externally managed. At least up to my understanding, last month we had a discussion. We were proposed a different API, so it is totally different. For self-hosted, there is an externally managed member, which will contains a list of IP addresses. I mean, the externally managed member IP address. So it's totally two different APIs.
Yeah, exactly. Two different APIs because of the same use case. You cannot take the pod identity from the stateful set in one case because you have two stateful sets, and in the other because you have no stateful set.
Yes, and some other reason also we have two different APIs. I don't remember what was the reason. Yes.
Yeah, but probably there is nothing really to do because in this case you have the dependency to the stateful set. I was just thinking whether there is any sense in generalizing the problem, but if it makes everything more complicated, then of course not.
Yeah, it was complicating it. When I had a discussion with Ranesh, I found that Ranesh and Madhav, we found that two different solution is better than complicating the system. So
okay, so
I don't remember the exact. Yeah, I don't remember the exact reason right now, but there was a reason. Yeah,
I will still write it down. Maybe you can check again and add the reason to the doc so that we know it tomorrow again. But yeah.
Yep.
Yeah, it was documented. Yes, I'll take it. I'll bring it back.
But given that Veteran already started this topic, I would also have some relation to the self-hosted shoots. and it is about the etcd member removal. If you maybe can scroll there. It's already there. Perfect. So you were talking here about creating some etcd ops task to remove the member. And I think for the self-hosted shoots, we were discussing a different approach where etcd Druid is calling a webhook on the backup restore, or webhook endpoint on the backup restore sidecar that has to be implemented. It doesn't exist today. But basically, etcd Druid would detect that the member is gone and that it should be removed. Maybe because it was removed from the etcd spec. I don't know exactly what the concrete trigger will be. Maybe because the node is gone for the self-hosted shoot. But in the end, Druid will do this automatically. So maybe we can also harmonize that.
Yes, that was an actually idea. So at point of writing this GEP, we have discussed initially with the etcd ops task, but as Renish brought up this idea of having an API endpoint in the backup restore, so we wanted to make use of a similar API only. We wanted to harmonize it. So this was decided at point of writing this GEP, etcd ops task. So
We don't
maybe
mind.
if
However, it is
self-hosted if self-hosted was using that API, we will use the same API. We will harmonize it. That was the plan.
How far will this go? I mean, there is history, lots of history. Stateful set was just a very, very easy way to get started many years ago. And some years back, we started discussing, okay, it would be actually better to have a self-managed solution. And that would actually help the self-hosted case because there it's you want to control the pods, and it would also help in this case because you want to add free and remove free, and bad things can happen, etc. So I'm wondering, do we now? So how much effort are we putting into this? Are we now redesigning the whole thing? Are we implementing 3 different solutions? One the classical hosting, one for self-hosted, and the other one for this control plane migration. How far do we want to go there? I mean, obviously you don't want to discuss self-hosted things with this concrete proposal about live control plane migration, and probably the other way around, it's the same. But it will add complexity to etcd Druid.
At least in terms of actually member removal part, it shouldn't be a bigger impact. It should be a simple API, should be exposed either in a backup restore or a normal. If we are using etcd ops tasks, there will be minimal changes in the backup restore. It shouldn't be a complicated one in terms of that one. So in terms of adding a member, additional member, those are all very minimal changes we bring in backup Druid. So it's overall, if you say in context of live CPM, it's a very minimal changes from the point of Druid and backup restore. So we'll try to harmonize with self-hosted and live migration also. So mostly it should be minimal, not that complicated.
I would like to move to another topic, a risk that I see with the 6-member cluster. Having 3 members on each side means that as soon as we lose connectivity between the seeds, we have a permanent quorum loss. Is that correct?
Yes.
So I was thinking about the alternative that you described with the 3-member cluster, where we would move 1 member at a time. The concern there was, and I understand it and agree with it, that when we expect to have 1 member like in a transition phase where we move it, it's unavailable, we can't lose another member. So I was wondering whether you considered like a 5-member etcd cluster where we have 1 member moving from source to destination, but we can afford losing another one without losing the quorum. isn't that a bit safer than having a 3 and 3 member cluster where losing connectivity is a permanent quorum loss?
How come, I mean, so there is only one member is a difference, right? I mean, are you saying, I mean, so
One
basically we
concern
will.
which I can say is like with 5 member is, since we want the QAPI server to be running at some point of time at both the clusters, source and destination, having 6 member gives the advantage that if the connectivity loses, the 3 HCD which is running in at one place, let's say in source, should not make and move ahead with all the things like make changes. With 6 members, the quorum will be 4. So at a time, we need HCD from the second cluster also to make the decision.
But is that really helping? I mean, even if the 3 continue, eventually network must be restored, or the whole migration fails, and then they will pick up again. So I think the point is, if you have 2, then you have a guaranteed outage, transient maybe, so not permanent, if the net, depending on the network connection, of course. And if you have 3 and 2, then you have at least a 50-50 chance, depending on which seat is impacted. But even if the one side continues working, I mean, the other side, as long as it's disconnected, it's not a big problem. If network connectivity is restored, then they can pick up again. But maybe it increases the complexity of the implementation. I don't know. But I see Tim's point that at least there is a 50-50 chance, and the other way it's 100% guarantee that it goes down. But then again, the time window
Yeah,
is
and it's
probably very small.
also the time in which we can be affected by the 50-50 chance of losing quorum is only very limited. If we if we add a new member on the destination seat before removing one of the old members, there's a short period of time where losing the connection between the seats will result in a quorum loss. Exactly the time where we have 2 on the new seat and 3 on the old, and then we add a third one on the new and remove the third one on the old seat. So exactly the situation with 3 and 3. But it would be very short in time.
Exactly, yeah. I would also think it's more theoretical because it happens so fast.
Right.
One issue with this thing was, so if you want to go with a 5-member situation or 5-member scenario, the things would be we need to scale both HCD as a part of same HCD object, or more or less like the HCD config should be same. And what I remember from the past discussion, we don't really want to support scale down in that proper way, where the 5-member goes 4, 3, and 2. I don't remember exact reason, but there was a discussion with Madhav, and then from HCD team, it was more or less like the scale down is to support the scale down in proper way. There will be a lot more implementation effort which will be required, and they were waiting for HCD members also first to implement a HCD member thing also before that, and there were some other things. That's why we went ahead with this idea, where the second HCD which is deployed in the destination is more or less a separate, deployed separately through the HCD thing, and they are so from Druid perspective, they are thinking they are separate, but internally they are forming a single cluster.
Okay,
So
basically the implementation is simpler because you add 3 and remove 3 is what you're saying.
Yeah,
okay.
And
I think that's reasonable. I guess.
And we don't support scale down anyway, as of now, right?
Yeah.
Native scale down from Druid.
I didn't get all the details, but it feels like we're choosing a higher risk because of simpler implementation. This is what I get.
Yes.
But you said yourself the time window is very short, so isn't it more a theoretical problem, or are we staying on free left, free right for a longer period of time?
We'll be staying that thing for quite some time, I guess. Yeah, till the time the QAPI server is removed from the source. Till that point of time, yeah. So there will be quite some time.
And what does that mean for a large cluster? Sorry, did you have numbers? Okay. I don't know whether you
20
mentioned
minutes,
them.
I think. It was 20 minutes, right?
So
for
it is not a
6 gig or
short period
something.
of time. It's actually considerable. And how large was the HCD? Is 20?
I don't remember.
Yes.
6 gig or
Yeah, it depends on the size of the HCD. Say if HCD size is lesser than a GB, it might take 6 to 7 minutes at the max. What we have seen is say most of the clusters size will be lesser. 99% of the cluster, 90% more than 90% of the cluster size is utilization was lesser than a 1 GB. So most of the time it will be 1 or 2 GB or less than 2 to 3 GB takes only 6 to 10 minutes. So beyond that, it depends on the network latency. Yeah, 20 minutes. Average latency what we observed is 10 to 20 minutes. If it is beyond 100 milliseconds, yes, it will take. Everything depends on the size of the HDDB size.
Is it even working with a very large HCD and lots of traffic? So I imagine if there are lots of controllers making lots of changes, then you're impacted by latency. Just getting over the data is throughput, maybe also latency. You just said latency. But if it's a very active cluster, then it can take hours if it completes it all. I don't recall the numbers. I think you had, and this is not in this proposal, but I think you once showed me some table with the test results.
Yeah, we did internally the testing, but yeah, it's not there. So thing is, for the traffic doesn't impact the migration time. Which the HDD DB size impacts it overall. So whenever the DB size HDD DB size increases, the total migration time will increase proportionally. It's a directly proportionally increased. So traffic doesn't matter. I mean, we have tested
we tested for traffic as well, right? While migration is happening.
We tested it around 600 RPS per second. RPS, everything works fine. With the lesser DB size and higher DB size also, we tested it around 6 GB. We tested it. It worked for low latency.
They seem to be some additional checks. So it's not only the latency between the regions, it's then maybe also how many changes happen on HCD.
Sorry, can you comment?
You mean revisions per second, or what did you just mean?
So we were trying to create an objects of a 200 let's say secrets and config maps on an API server load. So basically there are a lot of secrets will be created, config maps will be created on a QAPI server. So that is the load I'm talking about. The load on the QAPI server. Multiple creates and deletes and updates.
While migration is happening.
While migration was happening.
Yeah, I'm just imagining that there is also a theoretical maximum, like there is a maximum in latency between the different regions. I would assume that this might also be a problem. They always need to catch up.
Till 180 millisecond, there was no problem. It was catching up because, yeah, it depends on.
And the load was kind of comparable to very huge clusters. Otherwise, I don't say we don't do it. I'm just saying maybe there is then some more thought necessary by the operators to decide whether they go for live migration or not. Because if it takes many hours, and runs even the risk of failing, they should be aware of that. So should be written in somewhere. Cannot be, depends on how large etcd is, as you said. This determines how long it takes. And if there are too many revisions per second, then this is also somewhat of a problem, at least, or prolonging the whole exercise.
We would need to throttle the API server in case we want to automate that, right? It's the same as for live migrating virtual machines. In that case, you replicate the memory and hopefully you can catch up with it. But if you can't and it takes too long, you usually throttle the CPU to make sure there are not so many changes in memory that you can catch up and find a sweet spot for migrating over. But I guess throttling the API server is not so easy.
Well, this is actually a good comparison, a good problem from a different domain. But the same.
See, what we observed is from our landscapes, there are a lot of seeds. It's in an average, I would say the 200 RPS is an average load on a QPP server. It can be any put or get or we analyzed it. So mostly 200 RPS, it doesn't impacted the live migration at a. We tested with multiple DB sizes. The DB size is a problem. Then RPS. It was a live CPM was very smooth. It went very well. So, since because we add one by one the members, HCD members, so it was trying to down the HCD leader will try to send in a whole full snapshot, and whatever the delta was will be very less, and it can able to cope up with a leader. So it was, I would say, it was easier. I mean, it was went smooth.
Okay, I mean, then we take your word for it. We expect that revisions per second is not a problem. In theory, I would expect it to be a problem. Let's see whether it will become one in practice.
So the problem is DB size. Let's say if it is a 3 or 5 GB, it might take a time to send in a snapshot from the leader to the member, the learner. So let's say on a time T1, there was a 4 GB of data size, DB size. It will try to send a DB with a compressed, let's say some GB. And if there was a revision deltas were there, and it will try to restore from the T1, and there will be a slighter deltas will be per minute. It won't cross. I might not think so. It won't cross GB. It should be MBs. We tested it. It worked. So basically the problem is the transport of a snapshot will take a time during migration while learning. HCD member learner. The network bandwidth, I mean the latency is matters.
Yeah, all I wanted to say is you have the data and you believe that's okay. In theory, I would expect problems. Let's see whether we see them in practice or not, and then maybe we can find a solution. I don't know how, with API priority and fairness, somehow influencing, somehow throttling, as Tim said, the API servers. But this is then more and more going into the direction of there is actually a downtime.
Yes.
Understood.
And Shasha, what about that problem where single data type is of more than 1 GB or something?
Yeah, the interesting point is, let's say a specific resource, let's say a config map, if it crosses beyond 2 GB or 3 GB, on an APS, I have seen this existing QPP server. If a specific resources is more than a 2 GB, if you restart the QPP server, it can't, because of a gRPC problem on a QPP server side. It is not able to download I mean, it's not able to get the data from HCD. So if a specific resource type, if it is beyond 2 GB of data is there, the QPP server, whenever it restarts, it is not able to fetch those, list the resources from the HCD. That issue is there, but it is not related to the live migration. It is exist for the normal HCD QBP, normal HCD cluster itself. Let's say on a normal shoot also, we will face the problem. A specific resource kind, if the resources are many and the size of the resources overall is exceeds 2 GB, then there is a problem. It is not related to life cycle. It is there. That is what we observe.
Maybe we can move to another topic and investigate that more in deep asynchronously. I would like to discuss the API design a bit, because right now the proposal outlines these two sections in the status for coordination between the two gardenlets, and the flow shows a back and forth handoff, like multiple rounds. And when reading into the proposal, I imagine the difference to a normal control plane migration to be rather minimal, just that there was some coordination involved in the beginning, let's say like this, or somewhere in the middle. And then either side is the leader of the operation. So during standard control plane migration, first the gardenlet is responsible to migrate, so back up everything and remove everything from the source seed, and then on the destination seed, the restore operation will be completely independent, right? And I don't like too much that we have this back and forth coordination between the two seeds, and especially not on like these individual steps. It feels like we have a flow where steps are API surface, so to say. And I would rather like to use something like conditions, like the source seed publishes a condition that the etcd members are or have been exposed and are ready to join new members. That would be one condition. It can be true, false, whatever, in progress. And similar to the other side, that coordination happens on these conditions instead of individual step names that have to be followed one after another.
You are muted, Sono.
Yeah, that makes more sense to do it through the conditions. So we can have some conditions like live migrate, and then accordingly step.
No, I think he was saying a condition for each of the steps mentioned here, right?
Then
yeah, probably we don't need a condition for every individual step, but just for the points where we need a handover to the other seed. Like exposing the etcds is ready, then this is a handover point, and then joining the new etcd members is another.
So this can lead to a lot.
Maybe to stop here, because we only have now 4 minutes left in this slot. I guess we cannot prolong it spontaneously. It's already late also in India. So any proposals how we should proceed? I think we have discovered a lot of open questions also. So some things, not really decisions, but mostly questions that should be clarified, or apart from the things that were already open in the proposal, right? So even the proposal itself had at least 2 things that were not yet fully clear. Partly the proposal was also outdated. We found 2 things that we discussed today that should have been already changed in the proposal, that are already clear that it will be different. So maybe we should have another round at some point with a more up-to-date proposal document then. That clarifies the questions. I have written them down. I will share them afterwards. Maybe we can then do another round on an updated and more detailed proposal document. Or any other ideas, suggestions, how to proceed.
Yeah, I would like that. A revisited proposal document based on the discussion we had today would be a better basis for a decision, I guess.
Sure.
All right, then I would publish my notes as usual in the website and the recording, of course, as well. And then we can maybe just schedule a new date in some weeks when the proposal was updated to discuss again.
Okay.
Okay.
Sounds good.
Cool. Then let's stop here. Thanks for joining. Thanks for this discussion. And have a nice day and evening.
Thank you very much.
Have a nice day.
Thank
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.